Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is first class in Matrices chapter. Matrices chapter is easy or difficult. This chapter is very easy if you are good in the concepts. In this class, what we are going to learn? You will learn the definition of matrix and how we represent the matrix. Representation of matrix is important. And we will learn types of matrices, in that row matrix, column matrix, rectangular matrix, square matrix, diagonal matrix, scalar matrix, identity matrix. In these definitions, diagonal matrix, scalar matrix, identity matrix definitions are important. After that, we will do exercise number 3.1 problems from NCERT textbook. So in this class, you are going to learn these things. The definition of matrix, what is element in a matrix, what is order of matrix, and few important points, and we will learn how we represent a matrix. You see, what is the definition of matrix? A rectangular arrangement of numbers is called matrix. Rectangular arrangement of numbers is called matrix. You observe here, I written numbers are functions. That I'll explain these functions when I am writing the examples. Now we will try to understand what is this rectangular arrangement of numbers with an example. Please observe these examples. You observe here, if you observe this arrangement is in which shape? This arrangement is in rectangle shape. We arranged these numbers in the rectangle shape. So the rectangular arrangement of numbers is called matrix. So, this is a matrix or not? Yes, this is a matrix. Now, you may confuse with this. You observe this matrix. You observe here, this is rectangle shape or square shape? It is a square shape. Then how it will be a matrix? What is the definition of matrix? Rectangular arrangement of numbers is called matrix. But it is a square arrangement of numbers. Is it a matrix? Of course. Because we know that every square is a rectangle. You know that every square is a rectangle. So whatever the arrangement we done here, that is rectangular arrangement only. So is the example for matrix or not? Yes, it is a rectangular arrangement of numbers. That's why this is the example for matrix. You observe this. Is a matrix or not? Rectangular arrangement of numbers. Yes, this arrangement is rectangular arrangement. So this is example for matrix. Here I will write one more example. Please observe this. Rectangular arrangement of numbers. Numbers means mainly we have two types of numbers. One is real numbers, another one is complex number. Something if you got a matrix like this, 1 plus I, 3, I, 2 plus I. This is an example of matrix or not? Yes. Rectangular arrangement of numbers. That means these numbers may be real numbers or complex numbers. This is the example for matrix. Now you see, rectangular arrangement of not only numbers, it may be functions also, is called matrix. You observe this example. In this, sin x is a function, 2x is a function, 4 is a constant function. So here, this is rectangular arrangement of numbers or not? Yes. So you learn the definition of matrix. You observe this. Is it a matrix? Is it a matrix? This is not a matrix. If you observe the shape of this arrangement, it is coming like this. The shape of the arrangement is like this. This is not a rectangle. This is not a rectangle. So, when you saw this type of arrangement, can we say it is a matrix? No, it is not a matrix. See, this is the first note. The numbers in a matrix are called elements. The numbers in a matrix are called elements. You see here, 1 is called an element of this matrix. 6 is called an element of this matrix. You see, 2 is an element of this matrix. Sin x is an element in this matrix. X plus 5 is an element in this matrix. Please try to understand. The numbers are functions. The numbers are functions in a matrix are called elements. Okay. Now, you observe this matrix. In this matrix, how many elements are there? 1, 2, 3, 4, 5, 6. Total 6 elements are there in this matrix. You observe this matrix. In this matrix, how many elements are there? 3 elements are there. 1, 2, 3. Now, we will learn about what is row and what is column in a matrix? The horizontal line of elements. The horizontal line of elements is called a row. You observe here. This is one row. Please observe this. This is a row. 1, 2, 3. This is known as first row. What is second row? Second row is 4, 5, 6. The horizontal line of elements is called row. This is known as first row. This is known as second row. And what is column? The vertical line of elements is called a column. The vertical line of elements. You observe vertical line. See, this is one column. In this column, what elements present? 1, 4. This is second column of this matrix. This is third column of the matrix. So the vertical line of elements is called column. Okay. Now we will try to understand what is order of a matrix. If a matrix is having m rows and n columns. If a matrix is having m rows and n columns, we just learned what is row, what is column. If a matrix is having m rows and n columns, then we say order of the matrix is m by n. Look here clearly, m by n, which is denoted by m by n. Here some people they read it as m into n. That is wrong. That is not m into n, which is read as m by n. If a matrix is having m rows and n columns, then we say the order of the matrix is m by n, which is denoted like this. For example, you come here. What is order of this matrix? To find order of the matrix, you identify how many rows are there. One row, first row, second row. How many rows are there? 2 rows are there. So you write first 2 by how many columns are there? First column, second column, third column. So the order of this matrix is 2 by 3. You observe this matrix. What is order of this matrix? How many rows are there? First row, second row. 2 rows are there. 2 by how many columns are there? First column, second column. So what is order of this matrix? Order of this matrix is 2 by 2. You observe this. How many rows are there in this matrix? Only one row is there. 1 by how many columns are there? 1, 2, 3. 3 columns are there. What is the order of this matrix? Order of this matrix is 1 by 3. Now the important one. The representation of a matrix. Many students confuse in representation of a matrix. How we represent a matrix? See, representation of a matrix. Whenever you see this type of notation, A equal to Aij of order m by n is a matrix. When they mention like this, it tells that this matrix contains m rows, n columns. And what is Aij? Aij is an element of a matrix. What is Aij? Aij is an element of a matrix which is present in ith row and jth column. You observe here. I am writing the element which is present in first row and first column. Then it is denoted like this. A11. In the suffix we written 11. So A11 means it is an element present in first row and first column. You see here. Now observe what is this element. This element present in first row. It comes under second column. So this element is A12. Similarly A13. This is first row, third column. If we go on, if we extend this further, this is which row? This is first row. How many columns are present in this? Here 1, 2, 3 like that. How many columns present? You observe this is a matrix with m rows and n columns. So how many columns will be there? N columns will be there. What is A1n? It represents, this is the element present in first row and nth column. A13. A13 means what? It is an element present in first row and third column. Further, if I write this, this is which row? This is second row. So A2, this is which column? First column. This is A21. What is this? This is A22. Second row, second column. Similarly, A23. Second row, third column. Like that. What is this? A, second row, nth column. This is A2n. So similarly we can extend this further. See what you will get? A31, third row, first column. A41, like that. Total how many rows are there in this matrix? Total m rows are there in this matrix. So this is mth row. Mth row, first column. M1. It's a mth row, first column. You see, this is what? If we extend this further, this is which row? This is mth row, and which column? Second column, AM2. If we extend this further, this is which row? This is mth row. Mth row, which column? Third column. So this is AM3. Further, if we extend this, here, further if we extend this, what you will get? This is the last element, which is present in mth row and nth column. So, if they are saying that A equal to Aij is a matrix of order m by n, then it looks like this. And you can observe that if a matrix is of order 3 by 2, that means that matrix contains 6 elements, like 3 into 2. So you can observe here 6 elements are there. Here this is the matrix of order m by n. Then how many elements will be present in this matrix? Mn elements will be present in this matrix. I hope you understand this class. The definition of row matrix, the definition of column matrix, definition of square matrix, and the definition of rectangular matrix. First, you see this row matrix. What is row matrix? A matrix which is having only one row is called row matrix. It is easy definition only. If a matrix is having only one row is called row matrix. You observe this is the example for row matrix. In this matrix, how many rows are there? How many columns are there? 1 row and 3 columns. This is the matrix which is having only one row. That's why this is the example for row matrix. You observe this matrix. This matrix is of order 1 by 2. How many rows are there? Only one row is present. That's why this is the example for row matrix. You observe this is the matrix of order 1 by 5. 1 row, 5 columns are there. This is the matrix having only one row. So it is called a row matrix. Now we will learn what is column matrix. You see this column matrix. A matrix which is having only one column is called column matrix. A matrix which is having only one column is called column matrix. You observe this matrix. What is the order of this matrix? 2 by 1. In this, 2 rows are there, 1 column is present. This is the matrix which is having only one column. That's why this matrix is example for column matrix. You observe this matrix. This matrix is of order 3 by 1. In this, 3 rows are present and 1 column is present. This is the matrix which is having only one column. So this is the example for column matrix. Now we will learn the definition of square matrix, which is very important. You see, what is square matrix? A matrix in which number of rows equal to number of columns. In a matrix, number of rows equals to number of columns, then that matrix is called a square matrix. You observe this example. What is the order of this matrix? Order of this matrix is 2 by 2. So, in this matrix, number of rows equal to number of columns. So, this is the example for square matrix. You observe this matrix. This is of order 1 by 1. 1 row is present, 1 column is present. Is it the example for square matrix? Of course, it is a square matrix because number of rows equal to number of columns. You observe this matrix. It is a square matrix or not? Yes, because number of rows equal to number of columns. One important note, A is a square matrix of order 3. What it means? In which number of rows and number of columns both are equal to 3. For example, you see, we can say this as square matrix of order 2. Square matrix of order 2 means it contains 2 rows, 2 columns. This is square matrix of order 1. This is square matrix of order 3. We use this notation frequently while doing exercise problems. A is a square matrix of order 3. It means this is a matrix of order 3 by 3. Now we will try to understand what is rectangular matrix. Rectangular matrix. A matrix in which number of rows not equal to number of columns. A matrix in which number of rows not equals to number of columns, then it is called a rectangular matrix. You observe this example. This is the matrix of order 2 by 3. In this, 2 rows are there and 3 columns is present. Number of rows is same as number of columns? No. So, this is the example for rectangular matrix. A matrix in which number of rows not equal to number of columns. You see this example. This is the matrix of order 1 by 3. In this, 1 row is present and 3 columns are present. So, number of rows not equal to number of columns. So, this is the example for rectangular matrix. In this class, we will learn about diagonal matrix. Is this definition is easy or difficult? Actually, this definition is easy, but there is a chance that you will confuse easily. I'll avoid that confusion if you watch this video till the end. What is definition of diagonal matrix? We have 3 versions for definition of a diagonal matrix. I written all the 3 versions here. In examination, if they ask what is diagonal matrix, you write any one of these 3 versions. Okay, first we will try to understand what is diagonal matrix. A square matrix in which all non-diagonal elements are 0. A square matrix in which all non-diagonal elements are 0 is called a diagonal matrix. Non-diagonal elements. You observe this example. What are non-diagonal elements? See, this 3, 4, 5 are known as diagonal elements. Whatever the remaining elements are there, they are known as non-diagonal elements. See, the elements A11, first row, first column element, the element which is present in second row, second column, the element which is present in third row, third column. These elements are known as diagonal elements. Remaining all elements are known as non-diagonal elements. You just remember 2 points in this definition. Point number 1. First of all, the matrix must be a square matrix. If the matrix is not a square matrix, it never be a diagonal matrix. Okay. Many students will say a matrix is said to be diagonal matrix. That is wrong. You should start with a square matrix is said to be diagonal matrix. It is important. Second point is what? All non-diagonal elements are 0. All non-diagonal elements are 0. If a matrix satisfies both the conditions, then we say that it is a diagonal matrix. You observe this B matrix. It is a square matrix or not? Yes. Number of rows equal to number of columns. So this is a square matrix. Second point. All non-diagonal elements are 0 or not? Non-diagonal elements. You observe these elements. These are non-diagonal elements. Non-diagonal elements 0 or not? Yes. The matrix satisfies both the condition. Then why you are confusing? This is a diagonal matrix. They are not saying anything about these diagonal elements. They are saying that non-diagonal elements are 0. So, this matrix B is a diagonal matrix or not? Yes, the matrix B is a diagonal matrix. Why? First thing, it is a square matrix. Second point, all non-diagonal elements are 0. Right? Okay, we will see the other version of this diagonal matrix. A matrix Aij of order n by n. See, this we learned in earlier classes about representation of n by n in itself indicates it is a square matrix. This square matrix is said to be diagonal matrix if Aij equal to 0 whenever I is not equal to j. Aij is an element present in ith row and jth column. For example, you see this element. What is this element? This element present in first row, third column. Is I equal to j here? Is I equal to j? No. That means that element must be 0. And you see A, 2, 3. Second row, third column. Where is second row, third column element? Here, this one. See, is 2 equal to 3? No. 2 is not equal to 3. That element must become 0. The element Aij is 0 whenever I not equal to j. You clearly try to understand this point. They not mentioned what is the element Aij when I equal to j. They are not mentioned that. They are just simply saying that when I is not equal to j, then that element will be 0. That means whatever here I written in first statement, whatever is there in second statement, both gives the same meaning. Right? You see the third version of this diagonal matrix definition. A square matrix. First of all, it must be a square matrix. A square matrix which is both upper triangular and lower triangular. Then that matrix is called a diagonal matrix. To understand this, you must know what is upper triangular matrix, lower triangular matrix. What is upper triangular matrix? A square matrix in which all the elements below the diagonal elements are 0. So this is upper triangular matrix. Similarly, what is lower triangular matrix? What is lower triangular matrix? A square matrix in which all the elements above the principal diagonal are 0. Then that is called lower triangular matrix. So you observe this matrix A. This is upper triangular. Yes, this is upper triangular matrix as well as lower triangular matrix. So this is both upper triangular as well as lower triangular. You observe this matrix B. This is also upper triangular as well as lower triangular. Now you see about this matrix C. C is a zero matrix. Is this matrix is a diagonal matrix or not? Many students confuse in this. Very simple. You just remember 2 points. First one, it is a square matrix or not? Yes, you observe this matrix, it is a square matrix or not? Yes, it is a matrix of order 3 by 3, number of rows equal to number of columns. It is a square matrix. Second point, all non-diagonal elements 0 or not? Non-diagonal elements only you observe. Forget about diagonal elements. You just observe all non-diagonal elements. All non-diagonal elements 0 or not? Yes, if a matrix satisfies these two conditions, as per the definition of diagonal matrix, we say that it is a diagonal matrix. You see, this zero matrix is a diagonal matrix or not? Yes, it is a diagonal matrix. This diagonal matrix is also denoted like this, DIAZ. That represents diagonal. What elements are there in diagonal? In diagonal elements are 3, 4, 5. So we will write like this. What this indicates? This indicates that diagonal elements are 3, 4, 5. All other elements are 0. This we can write like this. This we can write it as DIAZ, diagonal 4, 0, 5. That means the diagonal elements are 4, 0, 5. And what about all other non-diagonal elements? They are 0. Now I'll conclude. What is diagonal matrix? A square matrix in which all non-diagonal elements are 0 is called diagonal matrix. What you should remember in a diagonal matrix? Diagonal matrix is a square matrix. And second one, all non-diagonal elements in that square matrix must be 0. You forget about diagonal elements. Diagonal elements may be 0, may not be 0. I hope you understand the definition of diagonal matrix. To understand the definition of scalar matrix, it is important you must know about diagonal matrix. You observe here, what is scalar matrix? A diagonal matrix in which all diagonal elements are equal. First of all, you must know what is diagonal matrix. What is diagonal matrix? Diagonal matrix is a square matrix in which all non-diagonal elements are 0. You observe here, this 5, 5, 5, these are the diagonal elements. Whatever the other elements are there, they are non-diagonal elements. You observe, it is a square matrix. In this square matrix, all non-diagonal elements are 0 or not, you observe. Yes, this is a diagonal matrix or not? Yes, it is a diagonal matrix. Before a scalar matrix, it must be a diagonal matrix. A diagonal matrix in which all diagonal elements are equal to particular scalar. For example, you see, diagonal elements you observe, what you identified, all the diagonal elements are equal. They are equal to 5 here. So, is it a scalar matrix or not? Yes, it is a scalar matrix. Why? Because it is a diagonal matrix, and in diagonal matrix, all diagonal elements are equal. So this is the example for scalar matrix. You observe this 2 by 2 matrix. First of all, it must be a diagonal matrix. Is it diagonal matrix or not? What is diagonal matrix? A square matrix in which all non-diagonal elements are 0. You observe 2, 2. These two are the diagonal elements. These are the non-diagonal elements. All non-diagonal elements are 0 or not? Yes, this is a diagonal matrix. In this diagonal matrix, all diagonal elements are equal or not? See, diagonal elements 2, 2. So, is it a scalar matrix or not? Yes, it is a scalar matrix. So, you understand what is scalar matrix. You observe here, identity matrix. Identity matrix is also known as unit matrix. You observe this definition. A diagonal matrix. First of all, it must be a diagonal matrix. A diagonal matrix in which all diagonal elements are equal to 1. Please try to understand. What is the difference between scalar matrix and identity matrix? In scalar matrix, all diagonal elements are equal to any scalar. But here, a diagonal matrix in which all diagonal elements are equal to 1 is called identity matrix. You observe here, this is a diagonal matrix or not? Yes, it is a diagonal matrix because non-diagonal elements are 0. And all diagonal elements are equal to 1 or not? Yes, you observe here, all diagonal elements are equal to 1. So, this is the example for unit matrix. Unit matrix is also known as identity matrix. You observe here, before identity matrix, it must be a diagonal matrix. You observe, is this matrix is a diagonal matrix or not? When we say a square matrix is a diagonal matrix if all non-diagonal elements are 0. You observe, These are the diagonal elements. You identify non-diagonal elements. All non-diagonal elements are 0 or not? Yes. So this is a diagonal matrix. A diagonal matrix in which all diagonal elements are equal to 1. You observe all diagonal elements are equal to 1. So this is the example for identity matrix. Now, very important point. Please observe. Is identity matrix is a scalar matrix? Identity matrix is a scalar matrix? Of course, identity matrix is a scalar matrix because it is a diagonal matrix in which all diagonal elements are equal. Try to understand. Identity matrix is a scalar matrix. Is every scalar matrix is identity matrix? No. Is every identity matrix is a scalar matrix? Yes. I hope you understand this point. You observe a note related to identity matrix. Identity matrix of order n is denoted by In. In general, this is, see here, in general, identity matrix is denoted by I. Identity matrix of order n is denoted by In. You see this is the identity matrix of order 2 now. This can be written as I2. I2 represents identity matrix of order 2. You see here, this is identity matrix of order 3 which is denoted by I3. I hope you understand what is identity matrix. Now we will learn very easy definition, that is zero matrix. Zero matrix. Zero matrix is also known as null matrix. It is very easy definition. A matrix in which all the elements are 0 is called zero matrix. A matrix in which all the elements are 0 is called zero matrix. It may be square matrix or rectangular matrix, whatever it is. In a matrix in which all the elements are 0, then it is called zero matrix. You observe this matrix. In this matrix, all the elements are 0. You observe this matrix. In this matrix, all the elements are 0. Yes, these are the examples for zero matrix. Zero matrix is denoted by letter O. It's not 0, letter O. Generally, matrices are denoted by capital alphabets. So, what is this? This is not 0. This is O. Zero matrix is denoted by O. In next class, we will learn about upper triangular matrix and lower triangular matrix. Definition of equal matrices. When we say two matrices are equal, you observe here, the definition is like this. Two matrices A and B are said to be equal. Two matrices A and B are said to be equal if it satisfies the following conditions. What are those following conditions? First one, they are of same order. The matrices A and B must be of same order. Suppose A is a matrix of order 2 by 3, B is a matrix of order 3 by 2, then these two matrices cannot be equal because first condition only failed. What is that first condition? The order of the matrices must be same. Here A is 2 by 3, B is 3 by 2, then those two matrices cannot be equal. When we say two matrices are equal, first condition, they must be of same order. And second condition, what is the second condition? Each element of A is equal to, each element of matrix A is equal to corresponding element of B. What it mean? I'll take one small example to explain this. X, Y, 1, 2, 3, Z. I taken a matrix. Now I'll take one more matrix. Okay. And this is like this. 4, 5, 1, 2, 3, 6. My question is, when these two matrices are equal. My question is, when these two matrices are equal. First point, they are of same order. You check it. What is the order of this matrix? In this 2 rows are there, 3 columns are there. So order of this matrix is 2 by 3. Okay. What is order of this matrix? In this matrix, 2 rows are there, 3 columns are there. So order of this matrix is 2 by 3. First point, both the matrices are of same order. Second one, what is the second condition? Each element of A, matrix A, is equal to corresponding element of B. Now you see here, this is the element which is present in first row, third column. You observe here, this is also one present in first row, third column. That means these corresponding elements are equal. Okay. And when it comes to these elements, these corresponding elements are also equal. Now the question is, my question is, when these two matrices are equal. See, as per the second point, each element of A is equal to corresponding element of B. See, this is the element present in first row, first column. This is the element present in first row, first column. If these two are equal, not only these two, corresponding elements of A and B are equal. That means X must be equal to 4 and Y must be equal to 5. Y must be equal to 5 and you see this one, Z must be equal to 6. Z equal to 6. I do one thing. What I'll do now, this matrix is there now. Here X is there now. X I'll replace with 4. In place of X you write 4. In place of X you write 4. In place of Y you write 5. In place of Z you write 6. Now you see this is 4, 5, 1, 2, 3, 6. 4, 5, 1, 2, 3, 6. The matrices are equal. This definition is very easy. When we say two matrices are equal, their orders must be same and corresponding elements in both the matrices must be equal. I hope you understand the definition of equal matrices. Upper triangular matrix. What is lower triangular matrix? And what is triangular matrix? We will learn about upper triangular matrix. What is upper triangular matrix? A square matrix. It is important. It is a square matrix. A square matrix in which all the elements below the principal diagonal are 0. Try to understand. It is a square matrix. Some people, they'll start writing is a matrix in which, it's not like that. You should write square matrix. A square matrix in which all the elements below the diagonal elements are 0 is called upper triangular matrix. For example, you see this. With this example, you can understand easily. See this example. What are the diagonal elements in this matrix? It is a square matrix or not? Yes, it is a square matrix. What are the diagonal elements? You see this 1, 2, 3. These are the diagonal elements. You observe all the elements below the diagonal are 0. So, in a square matrix, if all the elements below the diagonal are 0, then we say that it is a upper triangular matrix. You can observe here, if we draw a line here, it forms like a upper triangular matrix. Similarly, you observe this. This is a square matrix or not? Yes. In this square matrix, what are the diagonal elements? 1, 3. You observe that all the elements below the diagonal are 0. So, what is upper triangular matrix? A square matrix in which all the elements below the diagonal elements are 0. Lower triangular matrix. See here, lower triangular matrix. A square matrix in which all the elements above the diagonal elements are 0. You see, a square matrix in which all the elements above the diagonal elements are 0. You can understand this easily with an example. You see these examples. See this. What are the diagonal elements? Diagonal elements are 1, 2, 3. All the elements above the diagonal are 0. See, all the elements above the diagonal are 0. So, it is a square matrix in which all the elements above the diagonal are 0. So, what is this matrix? This matrix is lower triangular matrix. You observe this is a square matrix or not? Yes, it is a square matrix. What are the diagonal elements? 3, 4 are the diagonal elements. You observe here all the elements above the diagonal are 0 or not? Yes, so it is a lower triangular matrix. You can observe here this numbers forms a triangle here. You see this numbers forms a triangle here. That's why this is known as lower triangular matrix. Now we will see what is a triangular matrix. What is triangular matrix? You see here a square matrix which is either upper triangular matrix or lower triangular matrix is called a triangular matrix. What is triangular matrix? It may be upper triangular matrix or it may be lower triangular matrix. Either upper triangular or lower triangular. If it is any one, then we say that it is a triangular matrix. You observe these examples. You see these examples. What is this matrix? This matrix is upper triangular matrix. Correct or not? All the elements below the diagonal are 0. Upper triangular matrix. Can we call upper triangular matrix a triangular matrix? Yes, of course. Because a triangular matrix is either upper triangular matrix or lower triangular matrix. You see this one. This is a triangular matrix or not? Actually, all the elements above the principal diagonal are 0. So, this is actually lower triangular matrix. Lower triangular matrix is also known as triangular matrix. So, we learn 3 definitions in this class. Upper triangular matrix, lower triangular matrix and triangular matrix. We learn definition of matrix, we learn types of matrices, all the definitions we learned in last class. In this class, we are going to do exercise number 3.1 solutions. I'll do complete exercise 3.1 in this class. Okay, but to understand this class, it is important you should know what is the theory part we have related to this exercise. Okay, this is exercise number 3.1 in NCERT textbook problems. Total 10 questions are there. It takes time, have patience and try to understand all these solutions. Okay, you please observe this question. Question number 1. In a matrix, they given a matrix A. What they are asking, they given 3 bits here. First one is what? The order of the matrix. Order. What is order? Order means number of rows by number of columns. You observe here how many rows are there? First row, second row, third row. Total how many rows are there? 3 rows are there. How many columns are there? First column. See, this is first. See, this is first column. This is second column, third column, fourth column. So, how many rows are there? 3 rows are there. How many columns are there? 4 columns are there. So, what is the solution for the first bit? Total 3 rows and 4 columns. So, the order of the matrix is 3 by 4. I hope you understand this. Now you see the second bit, what they are asking, number of elements in that matrix. In theory part, we learn if a matrix is of order 3 by 4, then number of elements in that matrix is 3 into 4. 3 into 4 is what? 12, right? However, by counting the numbers in this matrix also we can write, okay? Total 12 numbers are there in this matrix, okay? How many elements are there in this matrix? Total 12 elements are there. What is meant by element? Numbers in a matrix are called element. Okay. Now this is important. Third one. Write these elements. What they are asking first? A13. Okay. Third bit. What they are asking? A13. A13 means what? The element present in first row and third columns. Look here. This is the first row. Where is the third column? This is the third column. First row, third column. What element? That element is 19. Okay. 19. Next, what they are asking? A21. Where is the element present in second row and first column? Second row and first column. Second row, first column. What is that element? That element is 35. Okay. Right. Next, A33. Can you answer what is A33? The element which is present in third row and third column. Yes, can you answer? What is the answer? Answer is -5. Very good. Next, what they are asking? A24. A24 means it is the element present in second row and fourth column. This is the second row. This is the fourth column. What is A24? A24 is 12. Good. It is 12. Okay. Next, A23. The element present in second row and third column. This is the second row, third column. Second row, third column. What is that? That is 5 by 2. Okay. So, A23 is 5 by 2. I hope you are understanding. Right. So, first question is over. Now, second question in this. You see what they are asking? What they are asking? If a matrix has 24 elements, they are not given order of this matrix here. They are just saying a matrix has 24 elements. What are the possible orders it can have? What are the possible orders it can have? This is one bit. And second bit, what if it has 13 elements? Okay, first let me do the first bit. What is the first bit in this? I'll suppose matrix is having 24 elements. Matrix is having 24 elements. Okay, what are possible orders? What are possible orders? We know that if a matrix is of order m by n, then number of elements in that matrix is mn. Okay. So here, if a matrix, how many elements are there here? 24 elements are there. Okay. 24 elements. What are the possible orders? What are the possible orders? I'll write here. The possible orders are. The possible orders are. The possible orders. What are the possible orders? 24 elements, na? 1 by 24. Is it possible or not? Yes, 1 by 24. Because number of elements in this matrix, number of elements of matrix of this order is 24. Okay. Now, come to the second one, 2 table. 2 into what number is 24? 2 into what number is 24? That is 12. Okay. Next 3. 3 into what number is 24? 3 into 8. Okay. Now 4 into what number is 24? 4 6 are 24. Next 5 into 6 into. Here you can observe one thing. Easiest way I'll write like this. See, 4 by 6 is there. Similarly 6 by 4. In this also number of elements are 24. 3 by 8 I written already. 8 by 3. 2 by 12 is there. I'll write 12 by 2. 1 by 24 is there. I'll write 24 by 1. So what they are asking, if a matrix has 24 elements, what are the possible orders it can have? These are the possible orders. Suppose a matrix is of order 8 by 3. How many elements will be there in this matrix? 8 3s are 24 elements. I hope you are understanding, right? Okay. Now in this second bit is also there. What is that second bit? If a matrix has 13 elements, look here. If a matrix has 13 elements, okay. 13 is a prime number. So 1 by 13 is one matrix. In that number of elements are 13. Okay. And what is the another one? Another one is 13 by 1. I hope you understand this, right? With this second question is completed. Now we'll see the solution for third question. Okay. See the third question. What is the third question? A matrix has 18 elements. Okay, no problem. What are the possible orders it can have? What are the possible orders it can have? It is similar to the last problem only, right? So start. First 1 by 18. Okay, now 2 table. 2 into what number is 18? 2 9s are. Next 3 into what number is 18? 3 6 are. Next 4 into what number is 18? Not possible. 5 into what number? Not possible. 6 into what number? Yes, 6 into 3. Actually, 3 into 6 is there. Simply you can write 3 by 6 is there. Simply you can write 6 by 3. Okay. See this 2 by 9 is there, 9 by 2. 1 by 18 is there, 18 by 1. You can observe all these orders. For example, you take this 6 by 3 is the order of the matrix, means number of elements in that matrix is 6 into 3. 6 3s are 18. I hope you are understanding, right? This is not yet completed. This is the first bit. And one more bit is also there. What is that one more bit? What they are saying, if a matrix has 5 elements. If a matrix has 5 elements, 5 is a prime number or not? Yes, 5 is a prime number. So then you will get 1 by 5, 5 by 1. That's it. These are the possible orders of matrices which is having 5 elements. I hope you are understanding. We will see the next question. See, this is a little difficult question. It takes time to explain. Try to understand. Construct a 2 by 2 matrix such that A equal to Aij whose elements are given by. What they are saying, A equal to Aij. This is the matrix. Okay. What is order of A? It is of order 2 by 2. It is of order 2 by 2. So whose elements are given by. Here you can see total 3 bits are there. First I'll do the first bit. Okay. First bit. In first bit, what they specified? They specified that Aij equal to I plus j whole square divided by 2. This information is given. You see here this matrix in representation of matrices. In last class we discussed about this. Aij of order 2 by 2. 2 by 2 means how you will write? We will write this one like this. See here. A11, this is the element present in first row and first column. A12, this is the element present in first row and second column. A21, this is the element present in second row, first column. A22, this matrix will be like this because it is of order 2 by 2. So what the point here, you need to find out A11, A12, A21, A22 values by using this Aij. Okay, what I'll do first, I'll calculate what is A11. You can observe here, in place of I, here 1 is there. In place of J, 1 is there. So in this also, wherever I is there you write 1. Wherever J is there you write 1. Okay, so 1 plus 1 whole square divided by 2. 1 plus 1 is 2. 2 square is 4. 4 by 2. 4 by 2 is 2 only. Okay. So I calculated A11. Now I need to calculate A12. Okay. A12. Okay. A12. You can observe here, in place of I, here 1 is there. In place of J, here 2 is there. So in this, wherever I is there you write 1. Wherever J is there you write 2. Okay. So in place of I, you write 1. In place of J, you write 2. Whole square divided by 2. 1 plus 2. 1 plus 2 is 3. 3 square is 9. 9 by 2. Okay. Next, you need to calculate A21. See, A11 I calculated. A12 I calculated. Now A21. A21. Second row, first column. Okay. You can see here, in place of I, 2 is there. In place of J, 1 is there. So in this, wherever I is there I'll write 2. Wherever J is there I'll write 1. Okay. Start writing. 2 plus 1 whole square divided by 2. 2 plus 1 is 3. 3 square is 9 by 2. Okay. Next, A22. You observe here, in place of I, 2. In place of J, 2. Right. Start writing. In this, wherever I, J is there you write 2. Okay. I, that is 2. 2 plus 2 whole square divided by 2. 2 plus 2 is 4. 4 square is 16. 16 by 2 is 8. So what happened? I calculated A11, A12, A21, A22. So what is the final answer? This is, yes, what is this? This, in place of A11, you write 2. Okay. In place of A12, look here. Look here, A12 position is here, 9 by 2, right? This is 9 by 2. What about next, A21? A21, what is A21? 9 by 2, 9 by 2, okay. Next, A22, what is A22? A22 is 8, okay. So, I calculated the matrix of order 2 by 2 such that whose elements are Aij is equal to I plus j whole square by 2. I hope you understand this, right? So here another 2 bits are there, second bit, third bit. I'll do one more bit. I'll do the second bit. I want you to try the third bit. Okay, let me finish this second bit quickly. Observe the second bit. What is Aij given? Aij is given as I by j. They given Aij as I by j. What they are asking? They are asking to construct a 2 by 2 matrix. That means they are asking to calculate this. Now we need to find A11 value, A12 value, A21 value, A22 value. First I will calculate A11. How I will calculate A11? In place of I, here 1 is there. In place of j, here 1 is there. Okay. So you write 1 by 1. That is same as 1. Okay. A12. In this, look here. In place of I, here 1 is there. In place of j, 2 is there. So in this also, wherever I is there you write 1. Wherever j is there you write 2. Okay. So what it will become? I by j, that is 1 by 2. Okay, 2 by 1. In place of I, 2 is there. In place of j, 1 is there. So in this, in place of I, you write 2. In place of j, you write 1. Okay, 2 divided by 1. That is same as 2 only. Okay, now A22. A22, I by j, na? That means 2 by 2. 2 by 2 is 1. So what happened? What is A11? Look here. What is A11? We got A11 is 1. Now what is A12? A12 is 1 by A12 is 1 by 2. Okay. Next A21. A21 is 2. A22 is 1. I hope you understand how to get out, how to construct a 2 by 2 matrix when they given like this. Similarly, third bit, I want you to try your own. Right? Now we'll move to next question. This question is similar to last question. This is similar to last question, but what they are asking here, construct a 3 by 4 matrix whose elements are given by. So they are saying it is a matrix like this, A equal to A is A. What is order of this matrix? Order of this matrix is 3 by 4. 3 by 4 means total how many rows will be there? 3 rows will be there, 4 columns will be there. So A is A. So I'll start writing that A11, which is present in first row, first column, A12, next A13, next A14, first row, fourth column, first row, fourth column. Okay, now next, which row, which column? This is second row, first column, second row, second column, second row, third column, second row, fourth column. Right? Now this is which row? This is third row. Third row. So what to write here? A31. Third row, second column. This is which row? Third row, third column. Which row? Third row, fourth column. So this is the matrix of order 3 by 4. So what to do? Now you need to find A11 value, A12 value, A13 value, A22 value. All these values you need to calculate by using the given information. I'll do first bit here. I want you to try the second bit. Okay, let me do the first bit. Okay, what they given related to A is A. In first bit, they given A is A is equal to 1 by 2 into modulus of minus 3i plus j. This is what they given. Okay, what you need to find? You need to calculate A11, A12, A13, A14, all those things. Okay, so you must know about modulus function, basic. First what I'll do, I'll calculate A11. In place of I, 1. In place of j, 1. Okay, start writing. 1 by 2 into modulus of minus 3 into, in place of I, 1. Plus in place of j, 1. Okay, that equal to 1 by 2 into modulus of, minus 3 plus 1. Modulus of minus 3 plus 1 is what? Minus 3 plus 1 is minus 2. Right? So modulus of minus 2 is what? Modulus of minus 2 is 2 only. Right? That is 2 by 2 is 1. So we calculated first element of this matrix. What is this? This is 1. Okay. A11 is over. Next what to calculate? I'll calculate A12. Okay. A12. In place of I, 1. In place of j, 2. Okay. Start substituting in this 1 by 2. 1 by 2 into modulus of minus 3 into, in place of I, 1. In place of j, 2. Okay, that equal to 1 by 2 into modulus of minus 3 plus 2, that is minus 1. Modulus of minus 1 is 1 only. 1 by 2 into 1 is 1 by 2. So I calculated second element also. What is that second element? 1 by 2. So next, what you need to calculate? A13. Okay, start calculating A13. Okay, A13. In place of I, 1. In place of j, 3. Okay, start writing 1 by 2 into modulus of minus 3 into, in place of I, 1 plus in place of j, 3. Okay, that equal to 1 by 2 into minus 3 plus 3 is what? 0. Modulus of 0 is 0 only. 1 by 2 into 0, that is 0. So what is this element? This element is 0. Now what you need to calculate? A14. Okay, A14. What is A14? 1 by 2 into modulus of, in place of I, what to write? 1. In place of j, you need to write 4. Okay, start writing minus 3 into 1 plus 4. That equal to 1 by 2 into modulus of minus 3 plus 4. Minus 3 plus 4 is 1. Right? That equal to 1 by 2. So finally, I am able to complete this first row. Right? Now I need to calculate all these values, A21, A22, A23, A24. Right, let's calculate. A21, A22, A23 and A24 I need to calculate. Okay, A21, you observe here, in place of I2, in place of J, 1 is there. So in this, what you will do? 1 by 2 into modulus of minus 3 into I. In place of I, 2. You write 2. 2 plus J. In place of J, you write 1. Okay. 1. That equal to 1 by 2 into minus 6 plus 1. That equal to 1 by 2 into modulus of minus 5. Modulus of minus 5 is 5 only. So this is 5 by 2. So A12 is 5 by 2. So here you got this value. This value is 5 by 2. Now next, what to calculate? I'll write here Aij. What is Aij? Aij is 1 by 2 into modulus of minus 3i plus j. Okay. Calculate A22. So in place of I, 2. In place of J, 2. Now in this, in place of I, 2. In place of J, 2. Right? That equal to, right, 1 by 2 into modulus of minus 3 into 2 plus 2. That equal to 1 by 2 into minus 6 plus 2. Look here. Minus 6 plus 2. That is minus 4. Minus 4. That is modulus of minus 4 is 4 only. So 1 by 2 into 4. That is 2. Right? Now A23. 1 by 2 into, in this, in place of I, 2. In place of J, 3. Right? 1 by 2 into modulus of minus 3 into 2 plus 3. That equal to 1 by 2 into minus 6 plus 3. That equal to 1 by 2 into modulus of minus 6 plus 3 is minus 3. That equal to 3 by 2. Okay. Now I need to calculate next element, that is A24. 1 by 2 into modulus of minus 3 into 2 plus j is 4. That equal to 1 by 2 into modulus of minus 6 plus 4. That equal to 1 by 2 into modulus of minus 2. Modulus of minus 2 is 2 only. That is 1. Okay. So what elements I got here? 5 by 2. Okay. 5 by 2 already written. 2, 3 by 2. This is 2. This is 3 by 2. Okay. Next, what we got? We got 1. That's great. Now what to do? We need to calculate these values. A31, A32, A33, A34. Okay. Now what I need to calculate? I need to calculate A32, A33, A34. What they given about Aij? What they given? They given Aij as 1 by 2. 1 by 2 into modulus of minus 3i plus j. Okay. Right. So calculate A31. Calculate 1 by 2 into modulus of minus 3 into, in place of I, you need to write 3. Okay. In place of j, you need to write 1. Okay. Yes. Minus 3 into 3 plus j is what? 1. That equal to 1 by 2 into minus 9 plus 1, that is minus 8. Modulus of 8 is 8. 8 by 2 is 4. Okay. A32, 1 by 2 into modulus of minus 3 into, in place of I, 3. In place of j, 2. That equal to 1 by 2 into modulus of minus 9 plus 2. That equal to 1 by 2 into minus 9 plus 2 is modulus of minus 7. Modulus of minus 7 is 7. This is 7 by 2. A33, 1 by 2 into modulus of minus 3 into, in place of I, 3. In place of j, also 3. That equal to 1 by 2 into modulus of minus 9 plus 3. That equal to 1 by 2 into minus 9 plus 3 is minus 6. That equal to 3. 6 by 2 is 3. Okay. A34, 1 by 2 into modulus of minus 3 into in place of I 3, in place of j 4, that equal to 1 by 2 into modulus of minus 9 plus 4, that equal to 1 by 2 into minus 9 plus 4 is minus 5. Modulus of minus 5 is 5 by 2. I hope you are understanding. So what values you got? 4, 7 by 2. I'll write all these things here. 4 I got here. Next 7 by 2. Next what values we got? 3, 5 by 2. Right. 3, 5 by 2. I hope you understand how to construct a 3 by 4 matrix when Aij is given. Right? Solution of this problem. Now we will move to next one. Sixth question. See this sixth question. What they are asking in the sixth question, find the values of xyz from the following equations. In this also 3 questions are there. Okay, so let me do any 2 questions in this. First question. Okay, see the first question. Here what they given that these 2 matrices are equal. When we say 2 matrices are equal, when the corresponding element, they already given 2 matrices are equal, so we can say that the corresponding elements are equal. See, first row first element in this matrix, first row first element in this matrix, both are equal. What I am trying to say, corresponding elements are equal. So what I can write here, y equal to 4. Okay, what they are asking, x, y, z values. Already y value calculated. Right, now what about this value? See, you observe these 2 corresponding elements. What you got here? You can write that z equal to 3. Good. Now corresponding elements, what you will get here? X equal to 1. What about these corresponding elements? 5 equal to 5. What? We do not want that thing. What we want? We want x, y, z values. You got x, y, z values. So first bit is completed. Okay. Now see the solution for second bit. Second bit solution. Here what they given, 2 matrices are equal means corresponding elements are equal. Okay. What I'll do now, I'll equate the corresponding elements. You see these 2, that means x plus y equal to 6. Okay. Now you can observe these 2. 5 plus z. 5 plus z equal to 5. So from this we can directly write what is z. You take this 5 to right hand side, 5 minus 5, that is 0. So you got z value. What is z value? Z value is 0. So we got z value. Now you observe here these elements. What I can write? Corresponding elements. xy value is what? As they given equal symbol here, xy equal to 8. Okay. xy equal to 8. What I'll do now? What I need actually? I need x value, y value, z value. Here I got an equation in terms of x plus y and xy. You know this formula. What is that formula? X minus y whole square can be written as x plus y whole square minus 4xy. Right, this we learn in 10th standard. X minus y whole square is x plus y whole square minus 4xy. Okay, why I written this? Because I know x plus y xy. I substitute here, I'll get x minus y value, so that I can calculate x value, y value. Okay, now you substitute x plus y value is what? 6 square minus 4 into xy is what? Xy is 8. 6 square is 36, 4 8s are 32. What you will get here? 4 you will get. Right? So what I can write here? X minus y whole square equal to 4. From this, what you say about x minus y? X minus y is plus or minus 2. So you got 2 equations here. First one is x minus y equal to 2. Second one is x minus y equal to minus 2. What I'll do? First equation, second equation I'll solve. Next first equation, third equation I'll solve. Okay. Now what I'll do? First I'll solve first equation. I'll solve this equation. Okay. First equation is what? X plus y equal to 6. Second equation is what? X minus y equal to 2. Solve them. just add what you will get, 2x equal to 8. So x equal to 4. You got x value here. Now in equation 1 or equation 2, I'll write equation 1. Equation 1 implies what is y? What is y? Y is 6 minus x. Okay, 6 minus what you got here, x value. X value you got 4 na? So in this, in place of x you write 4. Okay, in place of x you write 4. What you got? 2 you got. So what happened? You got y value as 2. What they are asking in this question, they are asking to find x value, y value, z value. So I got first set of solution. What is that? X is 4, y is 2, z is what? Z is 0. But there is another possible values also possible, because I didn't use this third equation. What I'll do now, I'll solve this first equation and third equation. Is, look here, x plus y equal to 6. I'll write here x plus y equal to 6. What is the third equation? You look here. What is the third equation? X minus y equal to minus 2. X minus y equal to minus 2. What I'll do now, I'll solve these two. Okay, again adding only. When we add these two, will get cancelled. 2x equal to 6 minus 2 is 4. So you got x equal to 4. Again this equation, from equation 1, what is y? Y is 6 minus x. This x value you substitute here. Okay, 6 minus 4, that is 2. So what happened? X value you got, y value you got, z value we already know it is 0. So second set of solution for this question came. X is 4, y is 2, z is 0. I hope you are understanding. See, please observe here. They are asking to find x, y, z values. I am doing the second bit here. What I did, I equated corresponding elements. Then this is the first solution. You'll observe here. This is the first solution. This is the part of the solution. Next, what I did, I solved equation 1 and equation 3. Then I got another solution. This is also part of the solution. I hope you are understanding. One more bit is there in this. This is the third bit. I want you to try. Or else I'll quickly do here itself. Please try to understand. What they given? X plus y plus z equal to 9. You observe here, x plus z is given as 5. In here, in place of x plus z, what I can write? 5. Okay, so y plus 5 equal to 9. So what is y? 9 minus 5 is 4. So you got y value. Similarly, in this equation, you observe here, y plus z is given as 7. Y plus z is given as 7. So x plus 7 equal to 9. X equal to 9 minus 7. X equal to 2. So you got x value, y value. Now substitute this y value in this y plus z equal to 2. See, y plus z equal to 7. Y plus z equal to 7. You substitute y value is 4. 4 plus z equal to 7. Z equal to 7 minus 4, 3. So x value is 2, y value is 4, z value is 3 for this third bit. I hope you are understanding. Now next question, seventh question. See the solution of seventh question. What they are asking, find the values of a, b, c and d from this equation. What they are asking here, they are asking that find the values of A, B, C and D when two matrices are equal. What do you know when two matrices are equal? Corresponding elements are equal. What is A minus B value? A minus B value is minus 1. And you see this element and this element. What is 2A minus B? 2A minus B value is 0. Okay. Now what I'll do here, I'll subtract. When I subtract here, minus plus minus will come. You know all these things. A minus 2a, that is minus a, equal to minus 1 minus 0 is minus 1. So what you got? You got a value as 1. So in ABCD, you already got a value. Very good. Now you take this as equation 1. From equation 1, what is B? Equation 1 implies what is B? B is A plus 1. Okay, in place of a you write 1. 1 plus 1 is 2. B is 2. is 2. Okay, you observe this one. 2a plus c is what? 2a plus c. 2a plus c is 5. What I'll do, this a value I'll substitute, in this equation. Yes, substitute 2 into 1 plus c equal to 5. C equal to 5 minus 2, that is 3. So you got C value. Now you need to find D value. You observe this, 3C plus D. 3C plus D equal to 13. You observe here, I already know C value now. The C value substitute in this equation. 3 into 3 plus D equal to 13. D equal to 13 minus 9. 13 minus 9 is what? 4. So you got 4 values A, B, C, D. I hope you are understanding. Just another 3 small bits are there. We can finish it quickly from now onwards. See this 8th question. What they are asking in this question. Aij is a matrix of order m by n, is a square matrix of order m by n. They are saying it is a square matrix. What do you know about square matrix? In a square matrix, definition of square matrix what? Number of rows equal to number of columns. A matrix is said to be square matrix if number of rows equal to number of columns. So what is the right option here? If m value is same as n, then we can say that it is a square matrix. Very simple. So third option is the right option for this. Now see this question. It is what they are saying. They given that find the values of x and y if the following pair of matrices are equal. What they are saying? They are saying these matrices are equal. They are saying these are equal. Then what they are asking? Find the values of x and y. For what values of x and y these two matrices are equal? What is the question? For what values of x and y given matrices are equal? Okay. What I'll do here? First element. Take the first element. What is that? 3x plus 7. What is 3x plus 7 value? 3x plus 7 value is 0. What is x from this? Take 7 to this side. 3x is minus 7. X equal to minus 7 by 3. I got x value minus 7 by 3. You observe this 2 minus 3x. Can you say what is 2 minus 3x value? 2 minus 3x value is 4. Okay. Take minus 3x to the other side. What is 3x from this? 3x is 2 minus 4. 2 minus 4 is minus 2. X equal to 2 minus 3x equal to 2 minus 4 minus 2. X equal to minus 2 by 3. What happened here? You can observe. What happened here? You got two different x values. When I put x equal to minus 7 by 3, you should get both the matrices are equal. But what happened here? When I put x equal to minus 7 by 3, this value will become 0. But this is not 4. This is not 4. Try to understand what I am saying. Actually, when I equate these things, you must get same x value. But what happened here? You got different x values. So observe the possible options. They are asking for what values of x and y given pair of matrices are equal. So what is the right option? Not possible to find. Because we got two different x values when we equate. We should get same x value. Right. Now, last question of this exercise. The number of all possible matrices of order 3 by 3. 3 by 3 matrices means how many elements will be there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 elements will be there in 3 by 3 matrix. Whose entries are 0 or 1. I'm going to use that permutations and combinations concept here. First element you take. First place you take. What are the entries you can write? You can write entries as 0 or 1. That means we can fill this first box in two ways. Okay. Into. The work is not yet completed. Second place. What elements I can fill here? I can fill with 0 or 1. That means two ways. Okay. Now what about this third one? I can fill this in two ways. Okay. Like that. Total 9 elements are there. 9 elements are there, right? So 2 into 2 into 2. 1, 4, 5, 6, right? So you will get these are the number of all possible matrices of order 3 by 3. The number of all possible matrices of order 3 by 3 with entries 0 or 1 they are saying. So how many possible matrices we can form? 2 power 9. 2 power 9. 2 power 9 is same as 512. So total how many possible matrices we can form? 512 matrices we can form whose order is 3 by 3 and the entries of that matrices are 0 or 1. I hope you are understanding. For an example, I can write 1 here 0 0 0 0 0 0 0 0 0 0 1. Right? You can observe here the entries of the matrices are either 0 or 1. I got 1. Like that, how many matrices you can get? You can get 512 matrices. I hope you understand this class.